Hi everybody, welcome to the second part of tool building and automation with Python in Houdini, the deep dive series. So this second part focuses on the fundamentals of programming with Python in Houdini. This is part 2.1, and in this part we will focus on working with variables, nodes and data. To recap what we discussed in the previous video, this will be a series of videos focused on the absolute fundamentals. Then after part 2, in part 3, we will actually program some projects from beginning to end. And in part 2b, we will also be looking at tools, skills and principles. But compared to this fundamentals section of the course, these will be much more advanced. And then in part 4, we will do some contextualization and we will actually interview some people who have actually programmed stuff with Python in Houdini. And I will add some masterclasses to this whole playlist in order to help you to make all kinds of decisions regarding Python in Houdini. And in this first video, we will be working with variables and working with Houdini nodes and parameters via Python. Before we start, there are a few things I would like to point out. In this video, we will be actually programming for the first time in this course. But I would like to introduce just a few ideas first so we know what we will be discussing. And secondly, the word variable might sound very simple. Most of you probably already know what a variable is, especially if you are already experienced in something like VEX. However, as you can see in this page, the list of topics that we will be covering is quite long. So I would like you to consider this video a deep journey into the world of variables with Python in Houdini. So of course we will first discuss what are variables and how to use them, the bare bone basics. We will be looking at examples of storing and using Houdini nodes as variables and parameter data using the hou.node class. Of course, we will also be looking at setting parameter values and creating new nodes with Python as well. But then after that, I want you to get a good intuition on how using variables makes working with complex code easier. Outside from the obvious, such as reusing code and less typing and so on. So for this, we will try to convert a mathematical equation into actual Python code that works on an object in your scene. On the same token, we will be analyzing the use of variables in production code. We will discuss how to use basic operators with variables, how and why to use your system's environment variables with Python in Houdini, using Houdini's global variables with Python, and accessing your node's local variables as well, including adding your own local node variables using the setUserData function. We will briefly discuss some rules to keep in mind when naming your variables, and we will end this video by looking at IDs and memory usage to get a basic understanding about the way Python actually uses variables behind the scenes. Without using any official programming language, when programming, we often use statements such as write some images to my hard disk, or grab some values from these specific nodes, or attach a value to that node, or change a parameter value on my mountain node, or adapt this part of my code to the user's current operating system, and so on. So these blue parts represent actions that we want to perform, but it's often easier and sometimes even necessary to store these underlined things in memory first, so we can call on them or use them in our code later on when writing the code to perform these actions. We do that with variables, and variables can represent all kinds of data types, and we will find several flavors of variables. General Python variables, your system's environment variables, Houdini's global variables, and your node local variables. We will learn how we can use Python to work with all of them in this video. Before we actually open Houdini, let's briefly define what a variable is. It's just a name that refers to a value. Values of different types like strings and integers and floats and so on. Why use variables? Well, variables can give data a handle and a descriptive name that you can use throughout your code. It will save you typing, it will make your code easier to work with and easier to read. So the assignment statement, looking like the equal sign, creates a variable and adds a value to its name. This name becomes a reference to an object that gets stored in memory. So without getting too theoretical, let's go into Houdini and start coding. Let's start looking at variables inside of Houdini. So we'll start simple and build up complexity from there. So I first will import this who module. I will explain why in a little bit, but let's focus on variables first. So my first variable is called my variable. So a variable is just a name referring to some value stored in memory. So the first value that we assign it is this string called my first variable. Make sure to add these quotes to make it a string. So if we open the shell, we can call this variable, printing it out to the shell, call it print my variable, and it will show in the shell. So we can use all kinds of operators to perform some mathematical operations on these variables. Here I have a value, 45, stored in this second variable. If we print it out, we can see it in the shell. We can add 45 to this and print that out, so we get 90. But we can also add values in the print statement as well. So we get 179 in this case. So we can use all kinds of operators. I will show a list of all of them in a short bit. Next, we have float values. Make sure to use a point and not a comma like this, because if you print this out, this would actually be a tuple. That is a comma separated list that can contain multiple values. So if you want to make this an actual float value, you need to add a point here. And then we have 5.9, like we show here. So besides floating point values and integer values and string values, we have also bool values. This can be true or false. Make sure to add a capital letter in front of the true or false statement when using bool variables. Then we have all kinds of variables containing multiple values, like I said before, like lists, tuples, dictionaries. I will discuss them in much more depth in a little bit, but I just want to show that you can add them as a variable and call these variables by just printing the name of the variable itself. Then we call all these values. We can also extract one of these values by just adding a number between brackets like this. We start counting at 0, so this fourth number will be the third value. So if we add 0, it will give us the value of 2, as we can see here. Again, we will cover lists and dictionaries and tuples in much more depth in a little bit. I just want to show some kinds of values that we can store inside of variables and perform simple calculations with them using operators. So here now, looking at a more practical example, let's create this variable called desktop and another variable. So this variable was a string, and let's create another string called file name and maybe another string called version. And let me call this version 3, for example, and then add another variable called extension. Let's just make it a hip file in this example. And we can then create a new variable called path, and we can use these operators to combine these string values. For example, desktop plus file name plus version plus the extension variable. And if we print this out, this path variable, we look at the shell, then we get a complete URL. But we have now a version inserted here as a variable, but this can be a string as well, as long as the type is the same. And don't forget these quotes, these double quotes in this case. So one thing about concatenation and adding these values together, you cannot just add everything together because the type has to match. So let me show this real quick. Let's say I have a variable called my number with a value of 89. And then I have another variable, let's call it my word. And this will be a string, something. So if we add those two together, let's add my word plus my number, we will get an error. So this will not work. We will get a concatenation error. So we cannot concatenate string and integer objects. So then we have to convert one of those to the other type. So let's convert this integer to a string by using this str function. We will discuss functions also much more depth in its own dedicated class. But now we get something 89. I added this space in the string because if we don't do this, it will just add them together without a space. So technically speaking, these are all objects. Python is very much object-oriented, and everything that we can store as a variable is an object. So we can also store Houdini nodes as objects and Houdini parameters as objects. So let's call this variable my node, and we can let's call this maybe geometry node to make it maybe a little bit simpler. And we can drag and drop this node inside of here, and we have this node stored as a object in memory and stored it in this variable geometry node. So if we print this geometry node out, we get geo1. But then we can add all kinds of functions on top of this stored value, for example the type, then it will give us the type of this node. We will look at this node class in much more depth in just a few minutes. One thing I would like to point out is that these variables are case sensitive. For example, I have here my word without any capital letters. So if we print this out using a capital my, for example, my word, then Python will complain and say, name my word is not defined. So this variable with a capital letter is not defined, which is true. So if I call this my word with capital letters, that's not defined either. So we have to make sure we keep a good eye on capitalization. As you might have seen, we use the print function a lot, but if you have multiple print functions, it can be very difficult to see where the actual output in the shell came from what variable it was originated. Let's see what we can do about that. We already know we can store Houdini nodes as variables with Python by just dragging and dropping it into a variable name. So now I have a variable fliptank and a variable flipsolver. So we drag the fliptank and the flipsolver to its own variable. And then we can also access parameters from these objects. So let's call this fliptank object particle separation, for example. We will store that value in a variable as well. So we grab this fliptank object and we just add the parm function, and we need to insert a name into this that we can see here. In this case, it's called particle sep. And technically this parameter is stored inside this variable. So let's quickly show what we get when we print this out. So we get an object. Let me open the shell real quick. So we get an, and let me delete this old stuff. And we get this particle sep, the whole parm. Let me clean this up to make it easier to see. So we get this weird kind of sentence just showing what kind of object that it is. So we are grabbing the actual object. If we add this eval function behind it, we will get the actual value of this parameter. So that's something to keep in mind. So with a parm, we can add a name of what we want to grab, and the eval will get the actual value, right? So let's do this again with the flipsolver timescale. So we grab the flipsolver object, parm, and then with the parm function, we can add what kind of parm parameter name. We can see it's called timescale. We can add in here, and then again eval function to grab its actual value, and we will print this out. So it's called flipsolver timescale, print it, and we get the value of 1, which is correct. So these are a few ways we can get these actual parameter values stored inside of variables as well. So now let's look at print. So let me do one example real quick with these parentheses, because it will work with parentheses, even though I advise you not to use them. But let me show you a few things first. So here I have this string, the actual value, and we stored that value in a variable already. So I showed you can use these operators, in this case plus, to concatenate them, to add them together. So if we grab this actual variable and we print it out, then it says it cannot concatenate string and float objects like I showed before. So we can convert this to a string, str, with the str function. And then it says the who is not defined because we had a typo before. So now we need to import who, then it will work. That's why I advise you to always import who first before you start coding. Otherwise, if you get a typo, it will complain that it cannot find the who name. Then another thing I would like to point out, so that's why we import this who in the beginning. So let me duplicate this real quick. I will show you a different method to print this out, because sometimes adding much of these concatenations can be real difficult to read and debug as well. So now we add these curly braces inside a string with the value of 0 in this case, and we will use this .format function. And here we can insert a variable, and since this is the first variable in this format function, it will be the first thing to be inserted in this 0 place of the string. So if we print this, we will get this sentence right here. So this can be sometimes easier to read, especially if you have multiple variables that you want to insert or combine with strings. in a sentence. So here we can do the same thing for this other variable. Well, in this case, maybe not the best example since we only have one variable inserted in here. So imagine you have to print out a sentence like this. So let's say I have a variable called first. Let's just call that first. Let's say I have a variable called second and a variable called third. Now, if you want to insert them here, so let me duplicate this real quick, then you can see it can be quite tricky. So if you want to add it here, first, and then you add this together. But as you can see, we already have to be careful. Do you need a space here or not? Because this will not contain any spaces. So it will be attached directly to this letter. So we will need a space here. And we will not need a space here if you want the comma to be attached to this word. And so on for the second and the third variable. So instead we can do this format function. And so you have the string. And then you attach this .format function right behind it. And then we can insert multiple variables inside of here. For example, first, second, and third. So now we have 3 variables in here. And we, just to show you something, we always start counting at 0. Let me comment this out. So we will always get 0, 1, 2, and so on. So this is 0, 1, and 2. So where do we need the 0 value? We need it here, so we can add 0 here. We need the second value here. But as you can see, it's quite easy to now read how the spaces relate to these attached values. So we can see where we need to add space. We can just keep this string quite clean and readable. And the third one, it needs to go here. And I can already see that this is correct in terms of the spacing. So if we now print, let me comment this out, just print out this sentence. If I didn't make a typo anywhere, let me see, first, second, third. So the error is that the, this is 0, 1, and 2. What this is saying is that the tuple index out of range, we don't have a number 3. So this needs to be number 2, 0, 1, 2, right? So if we print this out, then we have, this is my first, my second, and my third inserted variable in the string. So this can help you out if you have multiple print statements to show inside of this shell, then you can distinguish where these print statements come from. For example, var1 is 45 and var2 is 90. If I print var1 and if I print var2, let me comment this one out now and add the is sign. If I print this, I will just get 2 numbers, but I don't know what variable this 90 came from, right? I don't know what a variable this 45 came from. So if I say var1 gives me the value something like this. I mean, this is number 2. And let me add the 0 inside of these curly braces. Value 0. So if I print this out, now I can be sure that this 90 value actually was originated by the variable var2. So you can write, of course, whatever you need inside of the string, but there are a few ways that we can make these print statements more reader-friendly inside of the shell. So to recap that real quick, sometimes you will need to print out data to the shell in order to see the values that are referenced by your variables. And you can print string literals and variables, or even a mix between both in form of an expression, like you see here. So the print function, you can use the print your variable name in order to see what values are stored in your variable. And you can use the .format function, because sometimes you would like to combine it with a custom string or text in order to identify where the value is coming from, how it was originated in the first place. And you can use the .format for that, like you see in the example below. Let us now discuss the hou.node class. As you can see in this breadcrumb, it's part of the who class in general, and this module contains all the submodules, classes, and functions to access Houdini in general. And as you can see here, if you scroll down, then you can see that there are a lot of things in here, ranging from geometry, file I/O, dynamics, all kinds of things. So I of course advise you to scroll down in this list to see for yourself what kind of classes and things are inside of here. But in this case, we are interested in this hou.node class because this will allow us to communicate with nodes inside of Houdini in general. So as you can see here, it returns a node object. And just take some time to scroll through this list yourself because you will find a lot of topics in here. And of course, during this course, we will do that quite a lot. So let's open the Python source editor and the Python shell. And you already know that you can store a geometry inside of a variable in Houdini. So let's create a variable called myGeometry or myGeo, maybe that's shorter to read, and we have this hou.node, as you might have seen before. In this case, with a string with a URL or the path to this specific geometry as an argument. And we can then attach all kinds of functions to this. But before we do something like create a node, we need a context. So one of the things you will store quite often inside of a variable is the context that we are in. So in this case, I'm adding the obj context because I will show you how to create a node with Python. But of course, that's dependent on the context that you're in. So nodes that we can create in the obj context will be different compared to nodes that we have available inside of a geometry context, for example. So if we use the createNode function here, then we have these options available to us. But if we go inside of this geometry, then we have a different list. For example, we have the mountain available here, but we don't have the mountain in this context. So if we then open this, we can see the name of a geometry node is called geo. And we can then use a createNode function inside of this obj context. And we just need to add a type and a name in order to add a node with Python in Houdini. So the type will be geo. We just learned that from opening the I information panel. And the name will be my first node in this case. So we then click apply and we added a new node inside of this obj context. What's important to notice is that we have this hou.node and we appended this function createNode on top of the hou.node object, so the obj context as an object in this case. So we can then create a short little scene with a few nodes inside of this geometry. So let me add a torus, a sphere, a grid, and a switch node. Switch and add them together like this. And maybe add another node like a null. As a matter of fact, let's go with an output node like this and connect them. So now we have a few nodes inside of this geo. And again, myGeo represents the hou.node class, right? And the hou.node again grabs a node inside of Houdini. So now we can append all kinds of things to this hou.node. So if I print myGeo, then I get this geo1 object. So I can then append things like the type of this node. In this case is the node type geo, like we learned before. This would have been another way to figure that out. But we can add all kinds of classes. For example, children. If we add this class on top of the hou.node class, which is what myGeo represents in this case. MyGeo is the same as the hou.node with this object. And if we print this, we get a list of all these objects that are inside this geometry node. As we might have seen already, we have the, we have the torus here, we have the sphere, we have the grid, and we have the output node and the switch node. So all these objects are in this available through this children function. To present this a little bit easier, you don't have to remember what I'm going to do right now. So let me call this my children. And let me just show you how to make this a little bit more readable. So if we print my children, you will get what we just got a second ago. This is still just the same. I just added a variable, my children. But now I can use a for loop. So for I in children, prints, it has to be my children. Children is not defined. I changed the name a second ago. So it has to be my children. As you can see here in the message, my children is a non-defined name inside of this code. So now if I print my children, you will see it like this, which is a bit easier to read. Again, we will discuss for loops and stuff like that in much more details later on. I just wanted to make it more readable so you can see what we are doing. To skip a bit, I added my geo.type, printed that out, gives us geo. If I add children again, it gives us the children. So it might not be a stretch to suggest that you might be starting to see a easy pattern in here, right? So next I will show a different function. But before I do that, let me add a new node inside of this geometry. Maybe a manager, let me see, managers, and maybe a shop network. And let me just add 2 material shader builders. One, I call this material 1. Let me duplicate that and call that material 2. Oh, material 2. I accidentally deleted that one. So like this. And if we go in here, there are some nodes inside, but I will show that via this function. So if we use my geo and then type all subchildren and apply this, then as you can see, we have quite a long, messy list of nodes inside of here. So let me use the for loop again to make this a little bit more readable. So if we call this subchildren, or subs, might be more typo friendly, and for I and subs, print I. And if we apply this, then we can see this long list of nodes. So if we then go inside of here, you can see the torus, the sphere, and the grid. Torus, sphere, and the grid. Then we have the switch and the output node. Then we have this shopnet. And then if you go inside, we have material 1, material 2. This is material 1, and this is material 2. And then we have 5 nodes inside of here. These are these 5 nodes. And then the same thing for material 2. We have 5 nodes inside of there, and these are these 5 nodes. So this all subchildren function will return to us all these nodes that we have inside of the object that we attached this all subchildren function to. In this case, my geo. So if I now add this mountain, and let me create a variable called my mountain, and we add this node on there, like you might have seen before. As a matter of fact, let me clean this up a bit without skipping the video, because that might be a little confusing, seeing the code all different all of a sudden. So if we print my mountain, and we add the .name function behind that, it will just print out mountain 1 in the shell, as you can see. But if we change this number to mountain 4, for example, so this is a different input than we have here. This is called mountain 1. So if I apply this now, then it says it cannot find this object, because mountain 4 is now, my mountain variable is now empty because mountain 4 was not in there. So if I change this back to 4, then it should work correctly again. And like I said before, we can add all kinds of functions behind this. One of those is params. This will show all the parameters inside of this one node. So if we go through this list here, as a matter of fact, let me reuse this for loop to make it more readable again. For I in, let me give this a name. Let me add this into a variable, or I can add this in here right away. So for I in my mountain params, print I. So we can see this group input. We have the center noise as a second one, the height as a third one, and so on and so on. Element size. So everything that's in here in this node is available now based on this params function. So if we change this height to 0.4, for example, and we want to access this, we can see it's called height. So let me create again a new variable. Let's call it my mountain height, and use my mountain because that's the object .param. Not params. Params is a multiple, and it will return all these parameters. And let's call this one height. And this my mountain param will just need a string as an input again. The params doesn't need that, so let me comment this out and add height. So let's print my mountain height. And it says the subnode object has no attribute height. But that's because I have a dot height instead of an underscore height, which is the name of the variable. So you have to be careful with those things. It's underscore height is the name of the variable. So if I print it, it should be correct now. So let me do the actual parameter name like I had before. Let me clean this shell up a little bit so you can see it better. So now we have this object of the height, but not the value yet, like I showed before. So we have to add the .eval function behind this. And if we print my mountain height, it will return the actual value of this height, which should be 0.4. So if I now print this, we have 0.4. So these are just some things that can trip you up. So little typos will cause some gray hairs, so every now and then. The main thing I would want you to understand right now is that we have now this hou.node object stored in memory in my geo. And we can attach all kinds of functions on top of that with the .function name behind it. And just to show another one, we have now this switch node, for example. Let me add that to a variable called mySwitch. Drag and drop it like this, and let's see what we want to do. Maybe we can make it active, so make it selected, so to speak. So if we now go mySwitch.setCurrent and set it to true, we can set it to false or true, and you have to make sure you capitalize whatever you insert in there. And so mySwitch is now referring to this node, right? I don't need a print statement, so let me comment this out. So I'm now setting my switch to true. And as you can see, my switch is now selected. You can do this with every node in your network, of course. But the main thing I want you to remember from this is that there are many functions that you can attach to this hou.node class. So if we then go back to the documentation that we saw before, and we have this long list of the hou.node class in this page, and you can see we used some of them. We used children. We used all subchildren, or all items, I mean. You can open these to see some examples or extra information or details. It will always tell us what kind of data it will return, a string or a tuple or a dictionary. So there are many functions in here, as you can see. We used the type before. We used all kinds of things that you might have seen already. The params we just used a few seconds ago. All params we used a few minutes ago as well. We will look at this, of course, in much more details later on in other classes. Of course, we will need those when we do these example projects inside of this course. Keep in mind that some of them requires extra information as arguments, as an input of the function or the method. And we will cover this in much more depth, of course, when we discuss how to create your own functions, how to use functions and things like that. So just for a brief recap, Houdini contexts, nodes, and parameters will be among the type of objects that you will assign into variables quite often. So here you can see a few examples on how to store common Houdini contexts. This can be a TOPS, a ROP, an OBJ context, whatever you need. And of course you need to access those when you want to use something like the createNode, because that's context dependent. Storing Houdini nodes themselves as variables, you can just drag and drop the node and see what kind of URL or path it will give you, like this. And it will attach the hou.node in front of it automatically. And you can store parameters as variables as well by using the param and then the name of the actual parameter. When you mouse over any of the parameter that you want to grab, it will give you the name that you will need to type in here. And then we can use the .eval function just right behind it, and it will give you the actual value of that parameter, not only the object of the parameter. And then on the same token, you can use the .set function and just insert a value in there, and it will write into that parameter in your node itself. As you might have seen, the hou.node class offers all kinds of nice possibilities. You already know that you can drag your node into the Python source editor in order to assign that to a variable. But then after this, you can use many useful functions by attaching them together with the dot notation. For example, I have here my thing, and it equals hou.node, and the hou.node class grabs a node, in this case called geo1, from the Houdini network editor, and stores that in this variable called myThing. So the hou.node class grabs a Houdini node, basically. And then using Python's dot notation, we can use all kinds of functions with this myThing object that we just created above. So, for example, we can say myThing.children, and it will return all the children of this node. We can say myThing.allSubchildren, returning recursively even all those children of those children. We can say myThing.type, returning the node type of the object. Sometimes you want to dynamically figure that out in the code. We can say myThing.parm and then insert a parameter name. This will return the object. We can then say parm, then tx.eval to return the actual value of that parameter. We can say myThing.evalParm with tx, which is just a shorter way to do the same. We can say myThing.parms with an s, and this will return all parameters of this node. We can say mything.setCurrent, and then with the word true capitalized in there, and it will make your active node the selected one, and so on. So keep in mind that some of these functions requires extra input arguments, and we will cover those in much more depth, especially when we discuss functions inside of Python in Houdini. After saving all of those values inside of variables in your code, you might also want to change them. So I want to show you how to actually change these parameter values, and also discuss a little bit more about creating nodes in a second. So let me grab this poles parameter inside of this mountain node. So we can then say poles.set 43, for example. Let me comment this out, and you can see the poles length is now 43. So we can use the set function to change values and parameters in every node in Houdini. So if I grab this mountain height data, let me delete this eval. Let me see. My mountain is the name of the node. I don't need the parm. So let me just grab this my mountain. Oh, as a matter of fact, I already had this here above a few lines on top of this. Let me delete this. So if I grab this my mountain variable, and we can say dot parm, so we grab a different parameter. In this case, let's go with element size. So it's called element size, like we can see in this pop-up, element size, and we can then say set, and then just add a value. Let me say maybe 3. If we set it, it will change to 3. So that's how we can set data in parameters. If we set it to 39, it will be 39, and so on. So this is quite an important function as well. You will use it a lot to change data, because sometimes people think the equal sign will be enough, but you need the set function to actually change the values of these parameters inside of Houdini. So the set function allows us to change something about a parameter that we stored in a variable, and the createNode allows us to add some node to a object that we stored in a variable as well. So I want to illustrate something about the createNode function. Basically, I want to illustrate how important context is with the createNode function. So now you can see me typing all these contexts, the out context, the mat context, the obj context. And we can of course add node inside of all of these contexts, right? So now if we then create a new node, so to do that, let us first type new geo. Let me do underscore new geo node equals hou.node. Now, as a matter of fact, I can call the variable my obj context like this, and we say create node with capitalized N again. And just to reiterate, what we insert here is the type and the name, like this, but as strings. So the type will be geo, because we are in the obj context, and the name will be my geo node. So if we then run this, it will be stored in the obj context, because that's what this createNode is attached to. But one thing you have to be careful about is this runs like it should, but if I then just add a new line of code here, for example, print something. So let me add print and then just say something. And if I run this code again, then it will add another my geo node, because that was the sentence before. So we will discuss this in much more depth when we talk about flow control and loops and things of that nature. That's just something I wanted to point out, because you don't want to add a new node every time you run the code. Secondly, I want to discuss the importance of context. So if we look at the name of this node, again, press the I and it will say it's called Torus, like this. So if we want to create this node, we can add it like new Torus, new geo node, which is the name of the geometry node we just created, and we say then create node. It will add a node inside of that, and again we need the type and the name. So the type will be Torus without a typo, preferably like this, and then comma the name, my object, my own Torus, like this. And if we run this code, it will add it inside of this node, and it will create a new node. And so we have my new node, and we have the Torus like this. Because again, we create node will act on top of its parent in this case. So if we then try to do the same thing in here, in this obj context, so let me delete this, or copy and paste this, I mean, and delete this whole sentence. So now it will create a new GeoNode. Let me delete the old one. In this my obj context, it cannot create a torus object because it doesn't exist in this list. So if I apply, it will complain about an invalid node type name. It doesn't exist, this name, as a type. What we do have, for example, is a let me say, let's just keep it simple and maybe add a null. So if I then add a null in here just to see what it's called, and it's called null like this. So if we use the same spelling, null without capitals, and let's call it my own null, and then it should work because now the context is correct. This name exists in this context. That's something I wanted to point out again. And it doesn't work without spaces, by the way. That's also something to remember. It will complain invalid node name because we are not allowed to use spaces when we create those names of those newly generated nodes. That's also something very important to remember. So to go back to our first topic, which was about the variables, when we create those new nodes, we need to access them, so we store them in variables like this new node, my geo, my mountain, but also these contexts that we have above, or parameter values like we have in this pulse variable right here. We will of course discuss many of those functions in this course, but these are just some examples on how to use variables in your code. Next, I would like to show you a way, or to give you an intuition on how the use of variables can make thinking through code much easier. It can lower the complexity of your code, for example, when translating some mathematics into code or things of that nature, things that might go a little bit beyond just adding two simple variables together. So to show this, I would like to create a fun little project with a pendulum. So to show this intuition or this idea, I need an example that might take someone at least a little minutes to figure out on how to translate something to code. This might work quite well for this example. So here we have this pendulum page in Wikipedia. So if we then just convert this to something similar to how code would understand it. So I'm using Wolfram Alpha to type in this equation. If you give me a second, we divide this by the Euler number to the power of the decay multiplied by time. So if we then hit enter, let me check this way. If we hit enter, we will get the actual equation that we will use, written out as a. I think I made a mistake in this little sign behind the Euler number. This needs to be this. So now we have the Euler number with, to the power of decay multiplied by time. So this, let's say someone sends you this little equation right here. So I will copy and paste this, open a geometry node with a tube. Let me set it to polygon and increase the height a little bit. I don't need it to be this thick though. I want the pivot to be somewhere else. So let me just copy this. Oh, I still have this in my clipboard. Let me delete this and do it like this. Oops, I did Control V again. Let me do it by hand real quick. Let me say copy parameter and then paste relative reference and then divide this by 2. So now I have it where I need it to be. Just real quick, I want to keep things clean. I will call this one tube 1 source and we'll just add a new geometry node. Let me call this one maybe tube animated, because we will create a pendulum out of this. Of course, you can model a much nicer scene for this example. But here I will just import the other object with an object merge, the tube source, and set it into this project, into this object. And we'll need a Python node. The reason I'm doing it this way, by the way, is because this Python node calculates every frame. It refreshes every frame. So, and we want it to cook every frame because we will want it to move like a pendulum. So let me delete all of this for now. Let us now import what we need for this example. Just these two will do for now. Because we need to do some mathematics, of course. So the first thing I would do is add this equation as a comment in this case. And one of the things I want you to really understand about the use of variables is if we look at this, we can see it's an equation that has two parts to it. So if we simplify this a little bit, just visually, we can say we have a times part 1 divided by part 2, right? So this is much easier to read and to understand, correct? So it's still the same idea, but without all these details and things. But the structure is still the same. We have part 1 and part 2. So I want to store eventually part 1 as a variable and part 2 as a variable. But before we do that, let's just add the things that we need. So I will add those things as variables as well. So we need amplitude. I will just insert some numbers here and we will change them in a little bit. Because that's the second things that makes a variable a variable. We can change those numbers and play with them and it will give us different results in the end. So we need time, we need velocity. I'm using who.frame to give us the actual frame number of the scene. I need velocity. Again, let me just add a random number in here. And I will make it a float. The Euler number is a constant in mathematics. So in this case, it's 2.718. That is important to keep it that way. The decay, again, we will just add a random number in here. We will change that up a little bit as well when playing with it. And we need the object to actually move. In this case, the object will be, what did I call it? Let me just use a source editor and just drag it in here. What we will want to change is this rotate value, RZ in this case. So let me add this, copy this, I mean, and I remember that I need, remember that I need RZ as the thing that I would need to rotate. Let me do it once again, but much cleaner, like this. Copy this, go back to the Python code that we have in this node and paste this. So that's the object, and the object parameter that we want to change, again, is the same as the object.parm, right? We've seen this before, and we need RZ as a string, as the actual value that we want to store. So this is the object we want to move with our equation. But again, like I said before, when simplifying this whole mathematical equation into code, we will, of course, first create the object we want to change. So we will use the set function for that. So we will set amplitude, and we will multiply that by part 1, like you see here, and part 2. That's the way these variables can simplify our way of thinking while coding this whole thing. So we will add a variable called part 1 and part 2. Part 1 will be sine. We can just use sine for this, but the way we type it is very specific. We cannot use sine like this because we need to add math in front of it. I will explain this in much more detail later as well. But in this case, we have this sine, and then inside of this, we need times time velocity. And in the second part, we need the Euler number, and we say Euler to the power of the decay times time, because that's what this equation needs. And the way we set to the power, I will explain this in this video as well, after this, in a little bit. So now we have this equation with this decay and time to the power of the Euler number, like here. So we will add part 1 and divide it by part 2 in this actual thing that we will set. So just looking at this, you should get an intuition on how these variables and breaking it down into little parts makes it easier. So if we now look at this error, we can say amplitude not defined. So I probably made a typo. Let me see, where's the word amplitude? Yeah, like this, amplitude, the way we typed it here. So if we run this again, Control Enter, and we will have our pendulum animation, like this. So that's the first thing I would like to point out about the use of variables. But again, the word is variable. We can change these numbers. These are the numbers that can make a tool fun to use. So just by changing some of these values, you can get all kinds of result, of course, from this, like this. So you can play along yourself by retyping this and just playing with these numbers just to see what it does. And of course, we will use more complex examples later on, and we will add to this and we will give it a user interface. But for now, just those first two things about variables can be quite good to have an understanding about, which is that it makes a complex problem simpler because it helps us to break it down into little parts and to make those little parts easier to name because we have our own names. So they are also easy to remember and to think about, to store in your brain and to use them in some kind of way. And secondly, these are the numbers we can play with and make them called a variable in the first place. So this next slide is for the real nerds among us. Consider this a little break because it has nothing to do with Python in Houdini. First, you might have seen us using the Euler number in that example. But did you know that there's a trick to help you memorize Euler's number up to 15 decimal places? Just remember that the $20 bill has Andrew Jackson on it. So the first number of the Euler number is 2. He was the 7th president, so put a 7 after the decimal point to get 2.7. And Jackson was elected in 1828, so put down 1828 next. He served 2 terms, so copy that and put 1828 a second time. So now we are up to 2.7, 128, 128. And his favorite triangle had a 45, 90, 45 degrees angle. So add a 45, 90, 45 to get 2.7, 128, 128, 45, 90, 45. And that's an easy way to remember Euler's number to 15 decimal places. Try to recall this story a few times in your mind and you will have this memorized in no time. And secondly, I believe Euler was one of the most interesting characters who ever lived. I strongly recommend you to watch any YouTube lecture by William Dunham on Euler. So now back to Python. I promised you to tell you a little bit more about these operators. You've seen me use the exponentiation operator in the previous example. So operators are special symbols that you can use to perform computations like addition, division, and multiplication. So we can use the plus icon to do addition. We can use minus to do subtraction. We can use this little star to do multiplication. We can use the slash to do division and the double star to do exponentiation. So looking at the example on the right, so we can then say 24 to the power of 2 with these 2 stars, and that's what we just used in the previous example. But keep in mind that multiplication is with this little star symbol and not with an X, like you might have used in regular mathematics or school. And in some other languages, you will need to use a caret sign for exponentiation, but in Python, that's a bitwise operator. When you divide by integers, the result will be integers. So both operands will be without commas. So the numbers to the side of those little signs are called operands. If you want 60 divided by 24 to be 2.5, then you need to divide by 24.0 and not 24. In Python 3, it would be a float by default, and the double slash operator performs a floor division, resulting in 24 right away. So just to illustrate this point real quick, let me change one of those values, for example, var2 to 3.0 and var3 to 10.0. So if we now use var3 and var2 in here, these are now float values as well, then we can see the answer becomes float as well. If we do integers, then the answer also becomes an integer. But some more practical examples of this is when you have to deal with things like time, because hours has 60 minutes and you often have to divide it by some minutes and so on. So let's call a variable hour and set it to 60. And let's call the next variable steps, maybe set it to 12, because we have 12 major blocks of 5 minutes in an hour. And if we divide hour by these steps, we get 5. Because we have steps of 5 minutes. But if we set the hour to 60.0, we get 5.0, because one of the two inputs in this case was a float value and not an integer. Not both integers, I mean. So this was a brief overview of using operators in Python. Let us now look at using environment variables with Python in Houdini. So let's imagine the next scenario. Let's say you have a variable called engine version with a string of value 1. We have an engine user with some username as a string, and we have an engine password. Let's set it to clever password, of course, maybe with an underscore in the middle. to make it extra safe. And if we print out engine user, let me open the shell again. Print, we get some user. Let me clean this out. We get some user. If we print out engine password, of course, we get the password and so on. But the point is, maybe you don't want this code. I don't want this in the code for everyone to see. This can be secretive data. So I don't want this part in the actual code, right? So we can then create environment variables in the operating system itself by just opening this environment variables tab. And then in here, we can add an environment variable. Let's call this engine version. And by the way, normally I would use capitalized letters for static values or constant values. But just for this example, let's do lowercase. It doesn't matter. Engine user. I'm just typing the same things we just typed in the Python source editor a few seconds ago. And engine password with some clever password. Okay, so now we have these three values in here as well. So now in Houdini, sometimes you have to restart Houdini, by the way, to make this work. After importing the OS module as well, we can change this to not have it stored in the code like this, but we can delete this and simply say os.environ, not environment, but environ, and then .get, and then the actual name. So not the value, but the name. So in this case, engine version. And we can do this again. So os.environ, and then .get, and then the second name, in this case, engine user. And then as a third example, os.environ.get engine password. So if we now print this out, so let me print all three. So we had engine version, we had engine user, and engine password. So you can see I get none for all three of them, right? So these appears to be empty. So if I now then copy this and restart Houdini real quick, and if we then open the Python source editor and paste the same code again and open the shell. So if we now run the same code and press apply, we will see version 7, some user, and some clever password. So this is an example of using environment variables with Python in Houdini. There is another way that we will get to a little bit later. So to summarize that, we can store important data about our code as environment variables. After sharing the code, that information that could possibly contain sensitive data stays behind in the machine as intended. Before we continue, I would like to offer you a few simple rules on naming your variables. So don't start with numbers. You can start with letters or underscores. Other characters in your variable can be letters or numbers. Variables are case sensitive. That's quite important. Variables accept lower and uppercase letters, but it's better to start with lowercase letters in most cases. There are cases when we would like to start with uppercase letters, like with constants or when using classes, but we will discuss that in much more depth later on in other topics. In Python 2, 31 words are forbidden because they are already assigned to Python. As you can see in this list, these are the words. But in Python 3, exec is not a keyword anymore, but non-local is, so that changed a little bit. And as you probably already know, you can already download a version of Houdini that offers Python 3 as its Python interpreter. And most importantly, maybe make your variables as meaningful and descriptive as possible. Attempt to avoid vague words or vague shortened words, because it will make things probably more complicated for you later on when reading your own code. So these are just a few simple rules that you need to keep in mind when using variables in Python. One other type of variables that you probably would want to have access to are Houdini's global variables. So let us create a new variable, and open the aliases and variables tab. Here you see some variables in the second tab, like hip and job and pi and so on. You will probably want some of those when you want to render something out, for example, when you want to create the URL. So here you can see this is our value, and we can say who.expand string. And let's first import the who module in case I make a typo again. Expand string is with a capital S. And then in here, you can add just the name of the variable that you saw in the previous list. So let's print value, and we see f, because now it's a little string. But when you say $f, it's the actual variable that you see in the variables list. So here I'm at frame 86, and it prints out 86, 178, 178. Similarly, we can say the hip name. This is but the actual hip name, since I didn't store this file yet. So if we go to this variables list, you can see this is the actual hip name that is stored currently in this file. Similarly, we can say pi, for example, that was also in the list, and you see the value that is stored in the actual variables list. But sometimes you want a specific value at a specific frame. So there's another way to do this. We can say who.expand string at frame. So now if we insert, it needs two values, two input arguments. So in this we have an expression, and we have the frame number, because we are asking for something at a specific frame. So the expression is the name of the variable. In this case, let's say $f. And then the frame number, let's just say frame 57. So the result will, let me print this out. So the result will be 57, because the value of f will be 57 at frame 57. So it doesn't matter now at what frame I am in the timeline. It will always give me 57 in this case. So this is something we will need a little later on when we create our own scripts and tools. But as you know, besides these Houdini global variables, there are also local variables, local to certain nodes. So if we now just add a simple grid and a mountain sub, and let's connect them. Normally, you can use Hscript expressions to add values in those type fields. For example, let's say we want this time value. So we can say, let's first grab the mountain sub itself. So we can drag this in here. So now we have access to the mountain sub, the complete mountain sub, and all its attributes and parameters and everything. Now let's say you want an expression like $f from in here. And if we play this, we are now animating the time parameter in this mountain sub based on the frame number. So now we have access to this mountain sub, right? I want to point out that you need two things to make Hscript expressions work in Python. So let me first show you what would happen if you forget to add the parameter value into this URL. So let's say we create a new variable called mountain expression. In here, you can call for the Hscript expression. So you can start typing Hscript, and you can see here on the bottom Hscript expression. And then in here we will just grab this, in this case this URL, just to show you what would happen if the URL is not complete. But you have to make sure you add this ch function and wrap it around the ch function. Also keep in mind, if you use double quotes for the total expression, you need single quotes in the expression in the middle, otherwise you will end the complete expression based on what you see here with green. So now we have this ch function and the URL in the middle. So let's print this to see what happens. So if I print this, the mountain expression, it would, first of all, I made a typo in the name. It's expressions, mountain expressions, as you can see here with the S. Let me rename this one. So now we get a value of 0, right? 0.0, which is not correct. Because in the URL, we are only accessing the mountain node itself, but not the actual parameter, not the time parameter in this case. So we need to add a slash into this URL and say time. So now if we apply this, we get 170 or 103, depending on where the cursor is in the timeline. So just to recap this real quick, let me add a comment. You will need to add the ch function in order to get the actual channel value, and also make sure you add the actual parameter name inside of the URL that you want to access with Python. So this is how you access Hscript values via Python. You can also manipulate Houdini's global variables via Python. First, let me show you something. Let's open the text port and set env, and you can see all these global variables. You can add your own variables as well. If you say set env, and then you don't use these double quotes because it's not a string as it would be in Python. But here on the bottom you can see some extra inputs that you can give it and extra information on how to use this command. You can make the variable local, and you can unset the variable, which we will see in a short second. But let's go back to this example. Let's call this my second variable, because I already have a first one that you can see above. Let's delete this quote, and you can simply say equals some value. So let's call it something or something else, because I already have something. If we then say set env again, you can see my value that I had and my second value that we just created. If we now go to these aliases and variables, you can see my second variable in there as well. So now we can also say, we can unset it and delete it by saying set env, and then we give it this extra command, -u, and we just give it the name of what you want to unset or delete. In this case, my second variable. And press enter. This one is the one being deleted, so let's press enter, and now I'll say set env again, and you can see my second variable is not in there anymore. So that's something you can do in the text port. You can add and delete variables like these via the text port with commands like this. Of course, you can use this user interface to add values, but I don't like deleting variables via the user interface. So another thing you might want to do is manipulating these variables via Python. To do that, we can use this putenv function and simply say putenv, and then we can add some arguments in here. It needs a name and a value. So let's call this one my third variable, or my third variable. And as a, let me close this, and as a value, let's call it again some value. Maybe we should say some random value, which is sounds a bit better. So now we can call this value that we stored in memory in this case, and say, let's call the variable some value, and just say who.getEnv, and then call the name of this variable, in this case called my third variable, my third variable. So we can print this out. So let's say print show value. Before I do that, let me open the shell real quick and clean this out a little bit. So let me say value with an E, and then print this out. We get some random value as expected. So this putenv and this getEnv, you might expect it to add it to this variables list as well, but it doesn't, as you can see here. But you can use those Python commands to change and delete and get these Houdini's global variables. So let's create a new variable called myVariable and give it a value of some value. So now you can see it in here. So again, let me import the who module. And let's update this variable via Python. So we can do a similar thing, say who.putenv, and then give it the name of the existing variable. So it's called myVariable in this case. And the new value should be, let's say dog, for example. So doing something similar as I did before. Let's now retrieve this value via the getEnv command. So we can say getEnv and then give it the name of the variable again. In this case, myVariable. And let's print this again, value. I always make this typo. Let's print this out again, print value, and we should get dog, like we see here. So we have now used putenv and getEnv, and now you can see it actually changing the values in this user interface window. And we can also delete a value. For example, we can say who.unsetEnv, and then give it the name of the variable. For example, not valuable. Let's retype this variable, and then run the command again, and you can see it being deleted. Another thing that Houdini artists do a lot is use Hscript expressions as local variables inside of nodes. You are probably familiar with many of these, as you can see in this long list that you can find in this documentation page. But we can also use Python variations of those. So let me quickly create a grid and just add something to this, like a mountain. And in this mountain, just to show you the normal way of doing this, you are probably used to doing something like this, using $F on the offset, and maybe make it slower by dividing it by 200, and it will move like this. As you already know, by default, these are set to Hscript, as you can see here, but you can set it to Python as well. And if we set it to Python, normally we use this local variable function, and then we can insert all kinds of values in there, like we saw on the previous documentation page. But just a few things that you might want to know is that we can use this int frame function. Let me play this. We can see it moving, and if we divide this by 200, we get this result. It's not doing anything at all in this case. But if we make it a different number, you can see it jumping around as if we are using $F instead of $FF normally. So what this does is, this is the equivalent to $F in Hscript. So it's just grabbing the integer variant of the frame. If we set it to frame, then this is the equivalent to $FF in lowercase. So now you can see it moving more smooth because it's grabbing those subframes as well. Similarly, we can use time in Hscript. So again, if we set it to int frame, it's a capital letter F. This is the equivalent of $F. And time is the equivalent to $T. If we use this, then we are using the actual time. And again, this is all lowercase. And you can see it moving like this now. So these are these $F, $FF, and $T equivalents that you can use right away with Python inside of this. Similarly, there are all kinds of internal variables that you are used to use with these Hscript expressions. So I will show that before I show the Python variation. So here you are probably used to using something like this. I'm now using the ymax variable. If we want to use something like this in Python, we need to use a different function. So let me reset this real quick. Set this to 1, the default. And we will switch to Python now. And we need to use this function, lvar, for local variable. And then we need to add the name inside of quotes without a $sign. So let me quickly repeat this because this is quite important. So no $, and let me say a comma, and in quotes. So this is how you use all these other variables in Python as your local variable. We can use all kinds of values in here, of course, that you might have seen in the previous list in the documentation page. Let me get it real quick. This is the list I was referring to. So there are all kinds of values stored as local node variables. Besides using these local variables, you can also set your own. Some that are saved with the scene file and some that are not, as you can see in here. You can also use these cached variations. These will store the value that is computed every time a node gets cooked. And so just to show you a practical use case example of this, let me simply create a grid. And again, maybe add a mountain sub underneath. And let me delete this real quick and open the source editor and the shell as well, the Python shell, and import the who module first and import time because we will need it in this example. I will show you why in a little second. So first, let me grab this mountain sub and store it as a mountain variable. And then let me create a timestamp real quick. So the timestamp variable will contain this string time.time function. This will simply grab a timestamp of the current time. So if we print this out, we get this value. Every time I print it, I will get a different value because time is moving on in the machine. So now we have this timestamp stored in this timestamp variable. So next, what I would like to do is to store a custom local variable inside this mountain sub. So let me create a variable called mountain user data. And in here, I will grab this mountain sub, mountain, and then dot set user data with a T. And then in here, I can use this to store the data. It needs a name and a value. So as a name, I will give it the name of my data, and then comma, which was a string, by the way. And as a value, I will give it the value of the timestamp. I have already converted into a string, so it will be a string when I insert it here. So if we apply this, let me show you a way to see this value first by printing it out. So in order to do that, I will grab this mountain. I will create a variable called test, and then grab this mountain and say user data with a capital D. So now we are grabbing that user data from the node. The name of the variable is my data. So if we print this test, let me quickly do it like this, and then we can see the value printed out. So now we are grabbing this timestamp from the actual node, as you can see here, by using the set user data and the user data functions. So now this is working fine. Next, I will show you how to use this more in a real life kind of example. So we will store this data as a comment on the node that will be visible. So every time the scene cooks, you will see the timestamp of when the node was being cooked. So if we set a test name here, you can see it as a comment. But I want to insert this value dynamically. So we can say mountain comment. To do this, I will grab the mountain node itself. I already did it before, but it doesn't matter if you use the mountain variable or this. In this case, let me set it to set comment. And then we are adding a comment into this node, dot set comment. And then in here, the comment will be the mountain user data that we used before. Mountain user data like this. Let me see. And this reads the user data. And the other one sets the user data. So if we apply this, I made a typo. I don't have who with double H. So let me set it like this. And we have user data as a comment now. As you can see, every time I click, it will update. And again, to get it more user-friendly, because this is called a timestamp, the value that this generates, but we can set it to a more reader-friendly, user-friendly format, or more readable kind of string by using the datetime way of working with this. I will dedicate in the advanced section a whole video on working with time and datetime and things of that nature. So let me quickly convert this to a string and set its value to. Before I add something, let me make some room in here. Let me count the amount of things that we have. I need one more. So let me set this to datetime. With this, we are now accessing the datetime module. And then we need, from datetime, we need a function called datetime from timestamp. So this is a function, so I need those. And then the timestamp itself, which should be a float, we called it timestamp. So I'm now converting the timestamp to a float again, because it was a string before, because we manually converted it to a string. So now we have this more reader, user-friendly kind of way of calling the timestamp. So again, the timestamp is a string, as you can see above, which we converted to a string. And this datetime from timestamp method needs a float. So from timestamp expects a float. As you can see here, we converted it now to a float manually. And the set user data as a whole needs a string. So the set user data should be a string. Set user data, user with a capital U and capital D, should be a string as well. And if we set apply, we have a, oh, I didn't import the datetime module yet, so let me import datetime. Let me import from datetime, import datetime. Again, I will dedicate a whole video to this later on, but now we have a more user-friendly kind of method of showing this. The point being that we now stored a custom local variable custom and local to this specific node, storing values that are relevant to this node only, and we created a custom user data to do that. So this is also something we can do in Python. Again, you can read the documentation about the difference between the cached variation and the non-cached variation, but this is how you can store your custom user data inside of your nodes with Python. If we look into the way data gets stored into RAM, we use heap memory and stack memory in RAM. For example, let's say we have a variable 1 and variable 2, both with the value of 17. Then the actual value is stored as an object, 17, and in stack memory we will have a reference, which will be a name in this case, a name and an ID. In this case, one called var1 and one called var2. These will both reference the object 17 that is stored in the heap memory. So consider whatever is stored in the stack memory as a reference, right? So var1, the object 17 is created in heap memory and a reference address stored in stack memory, which we will see in a bit. In other languages like Java and C, the actual primitive data is stored in 4-byte or 2-byte into memory. In Python, var1 is a name referencing to the object 17, and in Java or C, for example, it's a memory allocation where 17 is stored. So if we have an ID of var1 and if we print an ID of var2, if we print this out, we will see the actual address, the referencing to that object, and you can see it's the same because they both reference the same object 17, right? This is very important, an important fundamental part of Python, also showing how object-oriented Python actually is. So if we create a new variable 1, 17 plus 1, in other languages like Java and C, it would override var1. But in Python, it creates a new object, as you can see right here. Similarly, if we create a new variable, var2, and we assign that the value of 17 plus 1, which will also be 18, of course. And then you can see it references the same object in memory again. So if we print out the actual value, you can see they, of course, both print out the value 18. So, of course, they are referencing the same object because that's how Python operates. If the reference count goes to 0 for an object, it gets garbage collected. It will be deleted from memory, so you can use that memory for other things. Later on in section 2b of this course, we will dedicate a complete class into memory management and optimizing your Python code. But this is something I wanted you to know right now because it's quite important. So we covered a lot of topics in this quite lengthy video, but then again, this isn't called the deep dive series for nothing. In our next class, we will be working with multiple objects, working with lists, with dictionaries, tuples, things of that nature. So working with multiple nodes, multiple groups and things like that. So I hope to see you there. If you enjoyed watching this video, please consider subscribing and hitting the bell notification button to get informed about when the next video will be released. And I hope to see you in our next class. Before we go, I would like to say that if you have requests about specific tools that you want us to make together in this series of videos, then please don't hesitate to contact me and let me know what kind of tools you would like to see programmed with Python in Houdini. I hope that today's topic will help you to get started programming with Python in Houdini. And if you do, please let me know how it went, or if you still miss some kind of information about the topics we already covered. So I wish you a lot of fun exploring Python in Houdini, coding things yourself, and hope to see you in the next video. My name is Da Costa, and until then, take care.